When you first dive into chemistry, one of the first things you will learn is significant figures. It is confusing, it makes no sense, and you find yourself at just a terrific start. In this video, we hope to reveal to you that significant figures, also known as sig figs, are not as complicated as they may seem. First, let's start with what significant figures are. In chemistry, we have to measure things. If we want to find the measure of liquid in this 100 milliliter beaker, we would be able to determine that the liquid is more than 80 milliliters and less than 90 milliliters. However, the exact unit digit is not clear. Here, we have to estimate. While I may think that it is 88 milliliters, someone else could view it as 87 or 89 milliliters. This shows us that when we measure things, we are approximating. Measurements always have some degree of uncertainty. Let's look at another example of this. If we measure a plant in a pot using a dial scale, you might see a number like 6.7 pounds. However, if we measure the plant in a pot using a less precise balance, we might get 6.6 pounds. See how the object has different weights depending on what you measure with? Because measurements carry uncertainty, it is very important that we understand which digits are certain and which digits are uncertain in a measurement. These certain digits are known as significant figures. So, how do we calculate the number of significant figures? In a measurement, any number from 1 to 9 is always a significant figure. For example, a bear weighs 685.73 pounds. In the number 685.73, we simply have 5 significant figures. The zeros are where it gets a bit tricky. If a zero is in between two significant figures like this, 105 pounds of bananas, the zero counts as a significant figure and the measurement would have 3 significant figures. This is because the zero here is an actual measurement, not a placeholder. The measurement of 105 pounds has an accuracy to the number 5, the unit place. This holds true even if the zero is followed by a decimal point and then a significant figure. If the zero is before the decimal point of a number, for example, a butterfly weighs 0.58 grams, then the zero would not count as a significant figure. There would only be 2 significant figures. The zero here acts as a placeholder, meaning that it just shows the size and is not an accurate number in the measurement. If the measurement has trailing zeros, the zeros would not count as significant figures. For example, if a farmer weighs a shipment of 2,300 pounds of strawberries, the zeros would not be counted as significant figures. This is because the zeros are only showing how big or small the number is, acting like placeholders. Following the same idea and rule, if the measurement is a decimal like 0.0182 ounces, the zeros would not count prior to the 182. The zeros are simply there to indicate just how small the number is. It is not an actual measurement of zero. If it is a decimal with trailing zeros like 1,642.10 grams, the zeros would count. The zero is telling us how specific the measurement is, not the size per se. The measurement was not to the nearest tenth, but rather measured to the nearest hundredth. Furthermore, if you have a measurement with a decimal point at the end, like this, 100 pounds, then the zeros would count as significant figures. The decimal point at the end signifies that this measurement was not measured only to the hundredths digit, but rather to the ones digit. One last point is that if something is a specific number, like 31 flowers, there would be infinite significant figures. The number is as accurate as it can get. I hope this video has made significant figures seem not as complicated. Please make sure to support UpScide by liking this video and hitting the subscribe button down below. See you next time!